ವೆರಿ ಗುಡ್ ಆಫ್ಟರ್ನೂನ್. ಇವತ್ತು ನಾವೇನು ಮಾಡ್ತಾ ಇದೀವಪ್ಪ ಅಂದರೆ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ಆ್ಯಂಡ್ ಇಕ್ವೇಷನ್ ಚಾಪ್ಟರ್ಗೆ ಸಂಬಂಧಪಟ್ಟಂಥ ಇಂಪಾರ್ಟೆಂಟ್ ಟರ್ಮ್ಸನ್ನು ಆಡಿಯೋ ನೋಟ್ಸ್ ರೂಪದಲ್ಲಿ ಸ್ಟಡಿ ಮಾಡ್ತಾ ಇದ್ದೀವಿ. ಹಾಗಾದರೆ ಹೆಚ್ಚು ಟೈಮನ್ನು ವ್ಯಯ ಮಾಡದೆ ಸ್ಟಾರ್ಟ್ ಮಾಡೋಣ. ವಾಟ್ ಆರ್ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್? ಅ ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ is a process where the reactant gets converted into product which may be under an influence of a catalyst. ಓಕೆ, ಆದರೆ ಯಾವಾಗಲೂ ಕೆಟಲಿಸ್ಟ್ ಇನ್ಫ್ಲೂಯೆನ್ಸ್ ಮಾಡಬೇಕಂತಲೇ ಇರಲಿಲ್ಲ. ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ದೇ ಆಕರ್ itself. Okay, you already studied in your previous classes what do you mean by physical change and what do you mean by chemical change. Chemical change brings a chemical reaction. A word equation shows a change of reactant to products through an arrow placed between them. Okay, what we have to do here, we place one arrow in between the reaction. The reactants are written on the left side. Okay, this is LHS, left hand side, and the products, okay, are written in what, right hand side. This is RHS. Okay, and whatever the reactants are there, in between them we write a plus. In between them what we have to write plus, and whatever the products are there, more than two products are there, means what we have to write there also we have to write plus. Then the arrowhead points towards the products and shows the direction of the reaction. Then how do we identify a chemical reaction? A chemical reaction is identified by any of these four factors. First one, which one? Change in state. Okay, change in state. Okay, solid turns into liquid, liquid turns into gas, or gas turns into liquid, or liquid turns into solid. Okay, change in state occurred means maybe, not definitely, maybe chemical reaction is occurred, because ice turns into water. It's not chemical change, it's a physical change. You already studied the difference between physical change and chemical change. I'm not going to explain that one here. Change in color. Okay, change in color. Okay, sometimes in some reaction change in color occurs. Evolution of gas. Okay, in some cases gas liberated. Change in temperature. Okay, reactions, sometimes reactions are exothermic or endothermic. Based on that, change in temperature also occurs in where? Chemical reaction. According to law of conservation of mass, matter can neither created nor destroyed in a chemical reaction. Okay, Anthony Lavoisier introduced a law of conservation of mass. Writing a chemical reaction. A chemical equation represents a chemical reaction. A chemical equation represents a chemical reaction. If you recall a formula of magnesium, oxygen, and magnesium oxide, the above word equation can be written as magnesium reacts with the oxygen O2. What it gives? It gives a magnesium oxide. It requires a balancing of this chemical reaction, because here oxygen 2 are there, here 1 is there. Okay, it's not balanced chemical equation. Then same they given in atomic structure. For example, what hydrogen molecule reacts with a nitrogen molecule, what it gives? It gives ammonia, NH3. Okay, then to balance this equation, what we have to do? We have to multiply. Here 3 is there, that's why we multiplied with 3. 3 2s are 6. Then here we take a 2. Okay, and then remaining equation is balanced. Okay, then in this chemical reaction, hydrogen reacts with nitrogen, and what it gives? It gives ammonia. Very important byproduct in chemical industry. Balancing a chemical reaction. To balance a chemical equation, first draw a box around each formula. Do not change anything inside the box. While balancing the equation, list the number of atoms of different elements present in the unbalanced equation. Start balancing with compound that contain maximum number of atoms. It may be reactant or it may be product. In that compound, select the element which has maximum number of atoms. Balance the unbalanced atom. Finally, check the correction of balanced equation. We count atoms of each element on both sides, LHS or RHS. Make a chemical equation more informative. The physical state of the reactants and products are mentioned along with their chemical formulae. The gaseous, liquid, aqueous, and solid states of reactants and products are represented by notations. Example: gaseous, G is denoted, liquid, L is denoted, aqueous, AQ is denoted, and solid, S is denoted. Okay, the word aqueous AQ is written if reactant or product present as a solution as or water. Then here water, hydrogen reacts with oxygen. What it gives a water. Hydrogen reacts with oxygen. What it gives a water. To balance this chemical equation, okay, what we have to do here oxygen one is there, here two are there. That's why to balance the equation we took here two. If we take here two means hydrogen turns into four. That's why we have to take here also two. Okay, this is a simple way of balancing chemical equation. If you want to if you are belongs to Karnataka, then go to chemical equations and reaction of my Kannada playlist. Okay, and there I explained very well with making one simple video. Okay, how to balance a chemical equation in simple way, and how to what to balance a chemical equation with quick steps. Okay, I explained. I think it's a highly view. Types of chemical reactions. There are five types of reactions we are going to study: combination reactions, decomposition reactions, displacement reactions, then double displacement reactions, redox reactions. Okay, mainly we have to discuss for redox reaction is different. Then uh, five types of a reaction, chemical combination. They give an example here. Okay, simple way: two or more elements combined to give one product. It is called a chemical combination. And what a single here they written wrong formula H2O. Okay, wrong formula they wrote. It's okay. It's a formula is H2O, not H2O2. It's a hydrogen peroxide. H2O2 is okay. Then whenever I think hydrogen peroxide only they decomposed. It's right. Okay, it's right. It's right. Very sorry. 1 minute. Hydrogen peroxide only they took. It's a one compound. It decomposed to give two products. Okay, that's also what. Mm, Decomposition. Then displacement, highly reactive element displaced low reactive element. Okay, it's a chemical displacement. Then double displacement, two or more compounds exchange their ions in between them and they give two new compounds. That's a what double displacement reaction. Then redox reaction, what happens, the oxidation and reduction, both reactions occur in a single chemical equation. That's called as a redox reaction. For example here, okay, methane oxidized because it turns into carbon dioxide, and the oxygen, okay, it lose its oxygens, it's what reduced. Then we have to see one by one these reactions. What is the definition example for this? Combination reactions. Okay, when two reactants combine to form a product, it is called as a combination reaction. Maximum one product. Calcium oxide reacts with the water. What it gives? It gives a calcium hydroxide. Okay, releasing large amount of a heat. Okay, it's exothermic reaction. Then calcium hydroxide reacts slowly with the carbon dioxide in air to form the thin layer of calcium carbonate on the walls. Calcium carbonate is formed after 2 to 3 days of a whitewashing and gives a shiny finish to the walls. It is interesting to note that the chemical formula for marble is also CaCO3. Reactions in which heat is released along with the formation of products are called exothermic reactions. Okay, burning of natural gas and decomposition of vegetal matter into compost are also example of an what exothermic reactions. Exothermic reactions are those reactions in which heat is endothermic reactions are those reactions in which heat is absorbed. Okay, those are called as endothermic reactions. During a digestion, food is broken down into simpler substances. For example, rice, potatoes, and bread contains carbohydrate. These carbohydrates are broken down to form glucose. This glucose combines with oxygen in the cells in our body and produces energy. This is a endothermic reaction too. Okay, whatever the reactions produce a carbon dioxide. Okay, those are exothermic reactions. For example, decomposition of a matter, burning of a biofuel gas. Okay, these are exothermic. Then endothermic, digestion of a food. Then endothermic reactions are those reactions in which heat is absorbed. Okay, during I told for you where in digestion or other reactions. Then decomposition reaction, when product break into its constituent reactants, the reaction is termed as a decomposition reaction. For example, iron sulfate with the help of heat gives iron oxide, sulfur dioxide and sulfur trioxide. Okay, a single reactant gives two or more products. It is called as a decomposition reaction. In this reaction, you can observe that a single reactant breaks down to give what simpler products. This is decomposition reaction. Ferrous sulfate crystals FeSO4 into 7H2 lose water when heated, and the color of the crystals changes. It is the what decomposes to what ferric oxide Fe2O3 and sulfur dioxide SO2 and sulfur trioxide SO3. Ferric oxide is a solid while SO2, SO3 are gaseous. Decomposition of calcium carbonate, the calcium oxide and carbon dioxide on heating is an important decomposition reaction used in various industries. Calcium oxide is called lime or quick lime. It has many uses. One is in the manufacture of cement, while a decomposition reaction is carried out by heating. It is called thermal decomposition. Then electrolytic decomposition. Three type of decomposition will occur because of heat, because of light, and because of heat, light, and electricity. Here, electricity. That's why it's electrolytic decomposition. It's called also electrolysis. See them. Take a plastic mug, drill a two holes at its base. Where drill here? What drill a two holes at its base. Fit rubber stoppers in these holes. Insert a carbon electrodes in these rubber stoppers. Connect these electrodes to a 6-volt battery. Fill the mug with water such that electrodes are immersed and a few drops of a dilute sulfuric acid to the water. Take a two test tubes filled with water and invert them over two carbon electrodes. Switch on the current and leave the apparatus undisturbed for some time. You will observe the formation of bubbles at both the electrodes. These bubbles displace water in the test tubes. We will see hydrogen at the cathode, okay, and oxygen at the anode. Okay, whatever the more amount of gas is collected, that's hydrogen, and less amount, that's oxygen. Then cathode and oxygen at the anode. The oxygen is double of hydrogen in the terms of volume. Okay, and it's a very important 2 marks diagram. Okay, what they gain here? 6-volt battery switch. Okay, whatever the positive terminal is connected, that's a anode. Negative terminal is connected, battery's negative terminal is connected, that's a what cathode. Rubber stopper. Then it's a mug. Okay, we took here water. In that water we added 2 to 3 drops of sulfuric acid. Then whatever the more amount hydrogen is collected where at a cathode end. Then oxygen is collected at where anode end. These are the test tubes, inverted cap test tubes and graphite rods we placed in the rubber. Then photolysis, thermal decomposition. Very sorry, it's not a thermal decomposition, it's a light decomposition. Light decomposition, photolysis it is called. Thermal decomposition is because of heat decomposition. Then halogen compounds decompose on exposure to sunlight. Halogen compounds, what happens? Uh, they decompose exposed to sunlight. For example, silver chloride. Silver chloride, what in presence of a sunlight contains a H nu of energy. Okay, then what they give? They give a silver and chlorine in the form of gas. Then photolytic reactions are used in a black and white photography. Where they are used in white and black photography. The decomposition reactions requires energy either in the form of heat, light, or electricity for breaking down the reactants. To breaking down the what? Reactants. Reactions in which energy is absorbed are known as an endothermic reaction. The reactions in which energy is absorbed from a system, from environment, it is called as endothermic reactions. Then photolysis, that's the same repeated they given. Then a displacement reaction. Third one now we are going to discuss. When an element displaces another element for its respective compound of a lower reactivity, it is said to be displacement reaction. In a simple way, high reactive element displaces low reactive element and give out new products. It is called as a displacement reaction. See here, for example, compared to hydrogen, hydrogen is a highly reactive. What zinc is a highly reactive. Zinc reduces or what displaces hydrogen, and what it gives a hydrogen in the form of gas, and zinc sulfate is produced. This is a displacement reaction. Okay, several displacement reactions we see. For example, what zinc reacts with iron sulfate, what it gives zinc sulfate, and it separates zinc sulfate and it separates what iron. Okay, examples of displacement reactions. See, compared to copper, zinc is a highly reactive, high reactive element. What displaces low reactive element, and what it gives a zinc sulfate and separating copper from copper sulfate. Then aluminum is higher reactive than copper, then it also displaces copper, and what it gives a aluminium sulfate, Al2SO4 thrice, and it displaces what copper. Then same, iron is more reactive than copper. Iron is more reactive than copper, that's why it displaces copper from copper sulfate, and what it gives iron sulfate and copper, separated copper. Okay, lead is also more reactive than copper, then it displaces copper, and what it gives product, Hmm, lead lead chloride, like that only. Calcium bromide and silver nitrate. Okay. This is what a double decomposition reaction will occur. Okay, I'm not going to discuss that reaction. A double displacement reaction. What happened? Double displacement reaction, the reaction in which there is exchange of ions between the reactants, are called double displacement reactions. The reactions are also called as precipitation reactions, as an insoluble substance is formed in which known as a precipitate. Any reaction that produces a precipitate can called as a precipitation reaction. Okay, double displacement reaction is also called as a precipitate reaction. For example, silver nitrate reacts with a sodium chloride. What it gives a silver chloride, and another one product, sodium nitrate, sodium nitrate, NaNO3. Then see here, silver nitrate, okay, and potassium, whatever the reactions are there here, insoluble what substance is formed, that's called as a precipitate. Okay, here also what uh, precipitate is formed. Then same, oxidation and what a reduction reaction, these are called as a redox reaction. Separately we have to discuss about what oxidation. What do you mean by element or compound gets oxygen? It's called oxidation. Element or compound gets oxygen, it binds with oxygen, then it's called oxidation. A element or compound lose oxygen, it's called as a reduction. Then in a single reaction, oxidation and reduction is occurring, then it's called as a redox reaction. If a substance gains oxygen during a reaction, it is said to be oxidized. If a substance loses oxygen during a reaction, it is said to be reduced. If one reactant gets oxidized while other gets reduced during a reaction, such reactions are called oxidation reduction reactions or redox reactions. If a substance gains oxygen and loses hydrogen during a reaction, it is oxidized. If a substance loses oxygen and gains a hydrogen during a reaction, it's also reduced. Okay, then what electron donor? Okay, electron donor, if any element donate electrons, means is what oxidation. If any element, okay, accepts electron, then it's a reduction. Then redox reactions example, methane reacts with a oxygen, it gets what carbon dioxide, then it's a oxidation. And oxygen, what molecule turns into oxygen atom, it loses one oxygen, that's a reduction. Okay, then some other examples they given here for oxidation and reduction. Corrosion and rancidity. When a metal is attacked by substances around it, such as moisture, acids, etc., it is said to corrode, and this process is called corrosion. The black coating on silver and green coating on copper are what other examples for corrosion. For example, black coating on silver, it may be silver sulfide or silver oxide, and other green coating on copper, it's a copper carbonate, because copper reacts with environmental carbon dioxide, it gives a copper carbonate. Like that only sulfur reacts with very sorry the what silver reacts with the sulfides present in environment and it turns into silver sulfide. Corrosion causes damage to the car bodies, bridges, iron railings, ships, and to all objects made up of metals, especially those of iron. Corrosion of iron is a serious problem. See here, car rusted because of iron. Then when fats and oils are oxidized by become rancid and their smell and taste changes, usually substance which prevent oxidation. Those are called as antioxidants. Those are called as antioxidants are added to foods containing fats and oil. Keeping food in airtight containers help to slow down oxidation. This prevents the food from becoming rancid. Hence, the chips are flush with nitrogen gas to prevent it from rancidity, because what nitrogen lowers the rate of oxidation. Okay, that's why in case of rancidity they use what in chips and other packets nitrogen gases to avoid rancidity. Okay, up to now we discussed chemical equations and reactions. Hopefully this video is useful for you. If you feel it's useful, please share and subscribe. Okay, and send your friends to join the group link. If a group link is not available, then what, send your name in class to this number 9481035821. Thank you.